Aging is the major risk factor for many modern diseases. Therefore, understanding the aging process could have a major impact in trying to alleviate those diseases. Aging is a very obscure and not well understood process. What is aging, we really don't know. We know the consequences of aging, but what are the causes of aging? And many of us believe that aging is not a plastic process. It's not something that we can manipulate. These observations indicate the opposite. When we convert a skin cell, for instance, into a stem cell, what we're doing is rejuvenating that cell. A skin cell was before a stem cell, and that's a process that we call cellular reprogramming, rejuvenating a cell back to its pristine state. This is a process we are right now working on in the lab to try to see if this is possible, not just in the Petri dish, but also in a living animal.
What we discovered is that we can change the program of a cell and an animal, and we can convert an old program into a young program. In this study, we were able to slow down aging by inducing cellular reprogramming both in a dish and in vivo. For this purpose, we use the factors that have been previously discovered that are able to reprogram cells to a pluripotent state. These are also called the Yamanaka factors.
These 4 factors are used to reprogram cells to earlier stages on development, so these cells seem to be younger. We were using these 4 factors in progeria mice, which are the premature aging mice, and also in one-type mice.
Previous studies demonstrated that long exposure of these animals to the reprogramming factor leads to cancer. The key for the success of this study was the cyclic exposure, short-term, to the reprogramming factor. Using this approach, we were able to make the animals live a 30% longer life.
The mice treated with these reprogramming factors had tissues that were better looking, they were more healthy, and they even didn't accumulate the aging hallmarks. And together, all these helped them in a prolongation of their lifespan.
An approach that we are taking right now is substituting these genes by chemical compounds. Compounds that you can take it one day, stop it, take it again, and see how things go. I think that will be much safer, much more secure, and could allow us to investigate whether that process can be applied into humans.